Okay guys, some of you may have already watched this video without volume. I apologize. I don't know why my microphone wasn't on, but we are going to try this again. We are on page 15 of your notes packet. I'm recording over my lunch hour, so you might hear some noise from people coming in and out, but we will do our best, okay? We are on page 15 and we are in lesson 7.2. We are talking about cube roots, okay? So the definition of a cube root here is a number by itself, here's the important part, 3 times, okay, we have 3 times, equals the given number. Okay, so a number that when multiplied by itself 3 times equals the given number. So some examples would be the cube root of 8, okay? So what number equals the cube root of 8? That would be 2. Because 2 times 2 times 2 equals 8. Or we could do the cube root of 64, which equals 4, etc., etc. Okay? Our symbol looks like this. Don't forget to put your 3 that represents the cube root. And then we don't really have types, but I do want to show you one thing. Okay, when we talked about square roots, you cannot have the square root of a negative number because a negative, you're never going to have a number times itself that equals a negative, right? A positive times a positive is a positive. A negative times a negative is a positive. So you can't have that. But you can, so you can have cube roots of negative numbers. Okay? So for example, if I take the cube root of negative, let's say 729, okay? We're doing a negative times a negative times a negative, okay? The cube root of 729 is 9. And then you have that negative, because a negative 9 times a negative 9 times a negative 9 is going to give you negative 729, okay? So that's just an example of why you can have the cube root of a negative number, but not the square root of a negative number, okay? We're going to keep on going down. We're talking about perfect cubes now, okay? And the definition of a perfect cube is a number that can be written, let's see here, with integer cube roots. Okay, and let's just talk about integer for a second. What I mean by that, for those of you who've forgotten what an integer is, it means that no decimals, no fractions, okay? So no decimals, no fractions. Okay, make sure you remember that. Let's just write that out, decimals. Okay, and the symbol, so like x to the third, okay? Some examples would be 1 is a perfect cube, 8 is a perfect cube, 27, 64, etc. Okay, and we're not going to do types. Find the cube root of 512. Okay, so make sure you don't forget to put your little 3 there, otherwise it looks like you're taking the square root, and the cube root of 512 equals 8. Okay, and then finally, if you look down at the bottom of the page, what is the relationship between finding the cube of a number and finding the cube root? Well, I hope you remember when we did this with square roots that you saw that it was they were inverse operations. So the same thing applies to cubes and cube roots. Okay, so we're going to say they are inverse operations. So now we got a bunch of inverse ops, right? We know addition and subtraction are inverse operations. We know multiplication and division are inverse operations. We've got square root and square, if you square something. So that's like an exponent. And we have the cube root, and if something is cubed. Okay, those are all inverse operations. That's how you undo them. Okay, going down to page 16. Okay, we've got some examples here. We'll look at 1A first. We're asked to find the cube root of 512. Okay, I hope you are starting to get the hang of your cubes and squares. That's going to give me 8. Cube root of 1 is just 1. I think we did this one on the previous page. The cube root of negative 729 is going to be negative 9. Yes, you can have the cube root of a negative number. Cube root of 1728. Okay, that's the biggest one you have to know. That's going to be 12. Here we have something interesting in 1E. We have the cube root of negative 125 over 343. Now I'm going to do this similar to how I did my square roots. I'm going to take the cube root of negative 125 over the cube root of 343, okay? Because that cube root is over the entire number. The cube root of negative 125 is a negative 5, and the cube root of 343 is 7. If I were you, while you're watching this video, I would have my yellow sheet out on the cube root, so you just work on memorizing those. Okay, the cube root of negative 64, we've got a negative 4. Cube root of 1,000, 10. And here we have one of those pesky decimals, okay? So how I do this is I rewrite it, right? I take out the decimal. And hopefully you know that the cube root of 1331 is 11. And then I'm going to add my decimal place back in. Now think about it for a second. You have 3 of them, right? It's going to be 11 times 11 times 11, but we're talking about a decimal. You want it to have 3 decimal places, and you add them, so we're going to add it right there. So it should be 1.1, okay? Moving on, it gets a little more interesting. If we look at number 2, we are talking about evaluating the expressions. Okay, I always deal with my cube or square root first. Here we have the cube root of 125, which we talked about being 5, okay? And how you read that is 3 times the cube root of 125. So we're going to leave the multiplication, and now we're just talking about our order of operations. We have 15 minus 8, which is 7, okay? The cube root of 27. Now remember what I talked about when we talked about square roots. When you square a square root, they cancel each other out. When you cube a cube root, they cancel each other out, and you're left with 27. Okay, 27 minus 4, 23. Okay, let's see here. We have 18 minus 4 times the cube root of 8. I'm going to deal with that cube root first. The cube root of 8 is 2. Okay, and then I'm going to copy down the rest. 18 minus 4, and that's 4 times. Okay, order of operations, multiplication comes before subtraction. And we should get an answer of 10, okay? Moving right along, we'll skip around a little bit. We don't need to do every single one. Again, we have a cube of a cube root, so those cancel each other out, and we're left with 64 plus 43. If you need to do that on the side, you can. What, 107? That's what I get. 5 times the cube root of 512. Okay, well, the cube root of 512 is 8. That's multiplication. Okay, multiplication comes before subtraction. So 5 times 8 is 40, minus 19. We're going to get 21. Okay, and these last 4 problems talk about evaluating. So they give us a variable, and we have to fill in what the variable is. So w over 30 minus the cube root of w over 5. Okay, I'm just going to take that 1080, and anytime I see a w, I'm going to plug it in. Okay, so we've got the cube root of 1080 over 5, okay? That 1080 over 30, if you do the math, you get 36. And then we've got the cube root of 1080 over 5. Now, 1080, let's see, is not a perfect cube, okay? But just like when we worked on square roots, look to see if you can do any simplification. Well, 1080 is divisible by 5. 1080 divided by 5 equals 216. So I'm going to go ahead and write that as the cube root of 216. And I hope you remember or recognize from your sheet that the cube root of 216 is 6. So 36 minus 6, you get an answer of 30. Okay, I'm just going to warn everybody that Mr. Jim, our maintenance staff, is going to come in a second, and he's going to, he cleans the room, and it's kind of loud, so it's going to get loud for a second. So I'll talk extra loud. He'll just be in here for about 15 seconds, okay? Next, let's do this one. I like 2G. Okay, we got the cube root of 8 times 64 plus 64, okay? So 8 times 64, I'm going to do that in my calculator real quick, just in the interest of time. Let's see. That's going to give me 512, okay? So the cube root of 512 plus 64. The cube root of 512 is what? 8 plus 64. We should get 72. Now, I want to show you something just so you're clear on something. Okay, you could have done this a different way. We broke out 8 and 64. If you wanted, you could have recognized that the cube root of 8 is 2, right? And the cube root of 64 is 4. And you could have taken 2 times 4 and still gotten your 8, okay? So if that confuses you, feel free to do it the long way, but you can do that shortcut to get nice, easier numbers, okay? Last one on this page, we've got, let's switch colors here. We've got 2 times b, and b is -3, minus the cube root of 9 times -3. Okay, well, 2 times -3 is -6, minus the cube root of what? 9 times -3 is -27. The cube root of -27 is -3. I've got some double negatives here, so we're going to get -6. That changes to +3, and my answer is -3. Okay, a couple more problems, and we're in the home stretch here. If you look at the next page, actually, let's skip. I'm going to skip that all together. Let's go to page 18, okay? We are on, let's write that, page 18, okay? And I want to look at 4b in the middle. Okay, if you look at this, the volume of anything, or I'm sorry, of any cube is going to be length. Okay, so this is what I warned you that Mr. Jim was going to come in. So just go ahead and bear with me. I'm going to talk really loud, and he will be out in just a second. Length times width times height. Okay, so just pause here for a second. See, 5 seconds. I told you it'd be quick. Okay, volume equals length times width times height. We know in a cube that all of our sides are the same. So volume equals side times side times side. And that's going to give you volume equals side cubed for a cube. Side cube equals 64,000, okay? We're going to cube root both because the inverse of cubing is cube rooting it. And I know that I didn't make you memorize one this big, but I hope you can kind of figure it out. That the cube root of 64 is 4, and the cube root of 1,000 is 10. So you're actually going to get an answer of 40 feet. Okay, that was a tricky one. Moving right along. Here we're talking about finding the circumference of a circle. Okay, show your work. And actually, you should remember from back with Mr. Robert and Mr. Harris that the formula for the circumference of a circle is going to be, well, you know what? I apologize because actually they give you the area, right? So we're going to do area of a circle equals pi r squared. I didn't read the problem, did I? Okay, so we have to find the radius. They give me the area, which is the cube root of 729 pi equals pi r squared. Okay, just like we talked about in class yesterday, go ahead and get rid of those pi's right away. Okay, I want to cancel them out. I'm left with r squared equals the cube root of 729. Well, the cube root of 729 is 9, right? And then we take the square root, because the inverse of squaring something is the square root, and we get r equals 3. Now, what I didn't realize when I did my first video is that they actually asked me for the circumference. Circumference is 2 pi r. So that's going to be 2 times 3 is 6, so it's going to be 6 pi is your final answer. Okay? And that's how you do that problem. If we flip to the next page, this is the last page, I promise you. We'll just do a couple of these. Let's see. We have to compare using less than, greater than, or equal. Okay, we have the negative cube root of 27. So I'm going to bring down my negative sign. The cube root of 27 is 3. And we've got negative 4. Okay, I hope you recognize that negative 3 is not as negative, right, as negative 4, so it's actually greater than. And let's do one more. The cube root of 64, that's going to give me 4. And the square root of 16, also 4. So we equal each other, okay? I lied, I want to do one more. Okay, I want to do this one because I think it's good it has those decimals. The cube root of 0.000 or 008, okay? You should know by now that the cube root of 8 is 2. So now it's just a matter of knowing where that decimal goes. Remember, we're going to do 2 times 2 times 2. So we have 3 of them, and we want 3 total decimal places. So we're going to do 0.2, 0.2, 0.2. So here, that equals 0.2, so you're going to have, oopsie, that's supposed to be a greater than sign. I think that is, why don't you do this and I'll check it. Do on your own. Okay, and you can go ahead and stop the video.